In this video, we are going to learn how to convert numbers that are already written in scientific notation into ordinary notation. To do that, we are going to move the decimal point. If the power of 10 has a positive exponent, we're going to move the decimal point to the right. If the power of 10 has a negative exponent, we're going to move the decimal point to the left. So right now there is an invisible decimal point right here after this 2. We're going to move that decimal point 4 places to the right. So there's going to be 4 zeros after that 2. And we are going to add a comma there to help us read that number. When we move the decimal point that's right here after this 9, 1 to the left, it's to the left of the 9. Then we need to do that 3 more times. So there's going to be 3 zeros before the 9. And we're going to put our decimal point right there, and we're going to put a 0 in front of it just for the sake of readability so that people see that this is a number that is less than 1. When we move this decimal point that's between the 7 and the 8, 6 to the right, the first time that we move it, it's going to go after the 8. Then we need to move it 5 more times to the right after that. So there's going to be 5 zeros there. And we're going to, every third place value like that, we're going to put a comma to the left of it for readability. Now we're going to move this decimal point 3 to the right, takes it 2 times to move it to this point, and then there's 1 more left. And we put a comma between the thousands and the hundreds there. I'm going to move it 3 times to get to this point, and then 3 away from 6, there's 3 left. 1, 2, 3 left. Put a comma there to show the thousands, put a comma there to show the millions. This next one, we're going to move the decimal point 5 times to the right. So that's 1 more. Then after that 5, 3, 7, 0, 4, 5, 0. Put our comma in there for readability. Now we're going to move the decimal point 4 to the left from where it's at right now. So there's going to be 0.0000393. If I move this decimal point 5 to the left, 0.1, 2, 3, 4 zeros, 5, 6, 7, 7. If I move it 6 to the left from where it's at now, 0, 1, 2, 3, 4, 5 zeros, 1, 2, 2, 9. And then we're going to move this decimal place 7 to the left. 0, so there's going to be 1, 2, 3, 4, 5, 6 zeros, 7, 0, 2, 8, 9. So you see that scientific notation is a way to help us write numbers that are very big or very small in a condensed form, and it helps us to see the digits that are what we call significant. So I'm just going to go through this, even though we haven't talked about it yet, and you can read about this in your textbook, that this has 1 significant figure, this one has 1 significant figure, this one has 2 significant figures, 3 significant figures, this one has 1, 2, 3, 4 significant figures, 1, 2, 3, 4, 5 significant figures. This one has 3 significant figures. This one has 4 significant figures, 4 significant figures, and 1, 2, 3, 4, 5 significant figures. And these numbers that are over here in ordinary notation have the same number of significant figures because the these leading zeros here or these trailing zeros over here are not significant. It's only the zeros that are between significant digits, like that 0 right there, that are significant. All right. Next time we'll come back and we will change some numbers from ordinary notation to scientific notation.